Hello everybody, this is Jenness, ready to pick up the lecture on geoprocessing and automation. So far we've discussed general geoprocessing, just discussing all those tools that are available to you. What does geoprocessing mean? We've also gone over environments, which allow you to run tools in different ways with different parameters. In this video we'll look specifically at Modelbuilder, which is a really nice way of stringing tools together to have one produce output that serves as input to the next. You can run a whole network of tools at once and save that whole process. Now the term model can mean a lot of different things depending on what you're doing. In ArcGIS, a model is specifically this set of tools that is hooked together to run through a whole sequence. And you build the tools in this model builder window, so we'll get lots of experience with that. But just to give you a quick example, suppose we have a scenario where we have some roads and we have a forest stand out there. We would like to designate a half-mile buffer around a specific set of roads, and we only care about the portion of that buffer that exists within these stands. So in this case we'd have to go through several steps. First, we'd select the roads we want to buffer. We would create a buffer around those roads, and then we would clip that buffer to our stands polygon. So it's a three-step process. You could do it easily enough with 3 different tools, nothing wrong with that, but you could also set up a model in Modelbuilder which connects all these tools together, and you can just run it all at one go. So it's pretty convenient way to do it. It's also a nice way where you can save the steps that you have done and be able to run it again later. Now here's a few more cool things about Modelbuilder. First, it's easy to delete intermediate data sets. So in that last example, we did 3 steps. We selected roads and we created a buffer around all the roads, and then we clipped that buffer to the stands. But that intermediate buffer, maybe we don't need that. All we really needed was the clip version. Well, if you do this all on Modelbuilder, there's functions that will easily delete that intermediate data set. Second, you can reuse your model over and over again. Maybe change a few different parameters each time. You can share your model with a colleague. If you put a lot of work into a process and this process would apply in other places, you can just send them the model and they can run it. Makes it easy to document the steps you have taken, and this is really important at the end of the project when you're writing up what you did and your results. Sometimes it's tough to remember all the steps you took in the exact order, and so if you can look at that model, you got it all laid out right in front of you. And finally, it's easy to specify which outputs should be added to your map. And in that last example, we did that 3-step process. We created the full buffer, then we did the clip buffer. Well, maybe we only want to add the clipped buffer to the map and not the intermediate full buffer. Well, the model lets us set which data set will be added to the map. Now, Modelbuilder is, actually building these models, constructing the sequence, running the tools, putting them all in order. This is really similar to coding. So those of you who are into coding, maybe do Python or Visual Basic or C++ or any of that, this will be really familiar. It's a visual way of doing it, though. You're not actually writing anything out. But you do have variables, you do have functions, you have intermediate data sets that get changed and added and deleted through the course of the process. And you can iterate through different features or through loops of counters, so in this sense it's very similar to a coding language. Now in this lab, we're going to do some basics models. We're going to use variables, functions, and intermediate data sets. We won't do iterations in this. That's just a little more complicated than we have to at this point. So we're going to learn the basics. Now, Modelbuilder is sometimes called a visual programming language just because it is so similar to writing code. Now, as a coder myself, I would argue that writing code still gives you a much deeper and more extensive ability to work with data. But Modelbuilder is not bad for what it does. In that example we just looked at, just 3 steps, that's not really where we would normally stop. Most models get much more complicated than that. And this, for example, this is a model I created to do some point density analysis once upon a time. You know, there's a lot going on in there. I'm basically calculating point density at various diameters around each point, doing some stats on it, then projecting the final rasters into some common coordinate system. And the net result of all that was to identify density of water sources down in the desert near Kingman. And here's another fun model that I did a while back. This was to calculate annual and seasonal current speeds using a bunch of ocean data sets. And I just like this model because it looks like a bridge to me. It's just sort of fun to look at. Now both of these models look like they have a lot of components, a lot going on, but I have a feeling that this level of complexity isn't really that uncommon for models. Most examples of models I see look about as complicated as these. So yeah, these are the kinds of things that you should expect to be able to do yourself in Modelbuilder someday. So enough examples. Let's look at some actual components of Modelbuilder. So let's understand what's going on in that window. First off, you're going to have 4 different shapes in the window. You got these oval shapes that are that stand for variables. They could be input data sets. They could be objects. They could be just numbers or text values. Then the rectangular objects are tools or processes. In Modelbuilder they call them a process, but they're really a tool. The lines are connectors which show how each process connects to each other. And when a process produces data, these lines indicate that data will be used as an input to the next tool. And then sometimes you see these hexagons, which are iterators. These things loop through objects. Like they could just run on a counter doing the process over and over again 10 or 20 times, or they could run through every feature in a feature class, or they can run through every data set in a workspace. In this lab we're not going to be using iterators, but they are available to you. Looking at variables, we have they'll be the ovals, but there'll be 4 different colors, and the colors indicate what those variables represent. So a dark blue is an actual data set, whereas green is a data set that is produced by a process or a tool. So the blue would be what goes into the process. The green is what comes out of it. Now these more cyan colors, these are values. That means they could just be a number or a text value. That's a different thing than an actual data set is a variable. This is that model we were looking at earlier, and here we see each component, but I've got it labeled so you know what type of object is there. So you see it starts with a blue oval, which is a data set. In this case it's the Coconino Roads. The first tool that it reaches is a tool that selects those roads. So you're selecting a particular type of road. This produces a green data set, and this is a green variable. This means that it's an output from the tool. So this green one is actually the same roads, but with a selection applied to it. That is an input to the buffer tool, and so the buffer then creates a new buffer feature class, which is that green oval there. Now we're going to clip it, and in this case we're using the green buffer plus a new dataset variable, the LeBaron unit. The clip happens and it produces a new derived dataset that is the clipped buffer. Now a few more comments about the design of Modelbuilder and the functions inside it. If the functions are marked with hollow objects like these empty oval and rectangle, that means that the dataset or tool or variable has been added to the model, but the model isn't ready to run. There's some parameters that have not been set. If these objects have solid colors within them, that means they are ready to run. And if they have solid colors with a shadow, that means that the run has already happened. So here are 2 examples of a model. In the top, we've added all the components, but we haven't set any parameters yet. And so that model is not ready to run, and it's apparent to us by the fact that those are hollow shapes. In the bottom, we've set several parameters for the first few functions, and those parts are ready to run. But you can see the clip tool still has not had all the parameters set, and so it is not ready to run. Here's a full model on top that is fully ready to run, and then after we run the model, then all those objects get little shadows under them, and so that indicates the model is complete. Now, there's some commands at the top of the model window that are worth knowing about. I really like especially the auto layout, and I like the fit model to window size. These are really handy tools, especially once you start getting a lot of functions and processes and data sets in that model. These tools help you keep organized. These commands are really cool and useful. So if you look at this example, this was a particular model that I've actually given you guys if you'd like to play with it. There's tools, processes all over the place in this, and this kind of thing happens as you're building a model. It just gets really disorganized. So there's this button called Auto Layout right here that just organizes them all for you. It makes them all nice and clean and neat. You can even change the direction if you do it in your diagram properties. Instead of going left to right as we have here, I can make it go from top to bottom. Hit OK, hit the auto layout again. It completely changes it for me. It makes it look clean and organized. And then this tool to go to full extent just zooms to the full extent of the model tools that you have. Now these are actually GIS tools that to be able to spatially arrange all these things in the model window. That's a GIS function, which I think is kind of cool. To set the parameters of any particular tool, you just double click on that tool or process. It opens up that same window that you're used to seeing. Here's where you set all the parameters for the buffer tool, for example. Really the only difference between this tool parameter window and the original tool parameter window is that this does not have a set of environment button. The normal buffer tool at the bottom had a button for environments, and this one does not. To set the tool environmental parameters for a tool that's already in a model, you just right-click on the tool and go down to Properties. Now let's consider the issue of intermediate data. These are the data sets that are created over the course of the model. They are not often necessary to save for later. They're just steps to get to the final product, and often we want to delete them after we're done. So this can be a really big issue when you have a lot of processes in your model and a lot of intermediate data sets. Consider this model we looked at a few minutes ago. This model produced a huge number of data sets as it worked, and I didn't need to save any of these for later. I would never use them again. All I did at the moment was fill up the hard drive. So I would like to delete them all, and it would just take quite a while to delete each individually. It would be wonderful just to hit one button and delete the whole batch at once. So to set a data set to be intermediate, all you have to do is right-click on it in the model, choose Intermediate in the drop-down menu, and then the model knows that data set to be intermediate, and it expects to delete it later. To delete all the intermediate data sets at one shot, you just click the Model menu, drop down to Delete Intermediate Data, and all that data is gone. Now here we have the option to decide whether any particular derived data set gets added to ArcMap automatically when the process runs. So we often make the very final derived data set add directly to ArcMap. So to do that, you right-click on the data set in the model and you choose Add to Display, and then when you run the model, this final product will be added right into ArcMap. You could do this to any of the intermediate data sets as well if you wanted to. Now let's talk about model variables. This is a way of making a model generic so you can use it with other data sets. This model that we've been discussing so far is hard-coded to do one particular thing. It's hard-coded to take the Coconino Road, select a particular road type, buffer it a certain distance, intersect it with a certain polygon, and produce a specified output feature class. It all works fine when we run it right from the model. We get this. We've seen this before. And that works fine if that's what you want to do. But suppose you want to do something a little different. Suppose you want to run it on a different set of roads. Maybe you want to do it on a different polygon. Maybe you want to have a different size buffer. And if you want to do it right now, you'd have to open up the model, go into each individual process, and set those parameters manually. And that's fine if that's what you want to do. But you can actually make it more flexible. Right now, you run it by clicking the little Run button in the model window. But there's other ways you could run it, where you could run it outside of the model window, and you just have to set these other parameters. Well, I'll show you here. Take a look. So there is a better way. If we set any of the parameters that we set for any of the tools to be a model level parameter, then the model won't run until you specify that outside of the model window. And it lets you run the model itself as if it was an individual tool. So, for example, this first tool that runs the model is a select layer by attribute. And it takes those Coconino roads and applies a selection to it using a particular SQL query string. If we double click on that select layer by attribute tool and open up the tool properties, here we can see the parameters we have hard-coded into that tool. We got the input data set to be Coconino, where the selection type is a new selection, and the expression is the SQL query, where we're selecting just this particular year-long highway legal vehicles class. Notice especially here that there's a parameter called selection type and another parameter called expression. Now we can set any of these to be what they call model level parameters. We do that by right-clicking on the process in the model window, go down to Make Variable, and then choose From Parameter. And notice we have those same two parameters, selection type and expression, what we just saw on the slide before. So if we choose one of those to be a model level parameter, and in particular we're going to make the expression, the SQL query, be a model level parameter, then the model window changes and shows this expression input parameter is hollow and with a little p above it. The p means that it is a model level parameter. That means it's a function that's given to the model itself before you run. Now we also should, if we're going to set model level parameters and produce new data sets each time, we should really set the output data set to be up to the user as well. The user should set the name and location of that instead of hard coding it right into the model. So we're going to right click on that output feature class, go down to model parameter there, and so now that has become an optional thing as well. Now you look at the full model. We have both the expression, SQL query expression, and the output data set to be model level parameters. We would save our model, we'd close it, and then we'd find that model in the Arc toolbox, and we just double click on the model itself, and it opens up with a little window that asks us to specify these two model level parameters. So in this case, we specify the SQL query we're going to use, and we also specify the output feature class. And if we run it on some other data set, and maybe we're buffering the limited Forest Service admin roads instead of the highway legal roads, well, we get a different buffer over a different region, and the model has become much more flexible. For those of you who are interested, Esri does have a virtual campus course on Modelbuilder. It's pretty simple. It covers a lot of things we've talked about here, but maybe with a little bit of different angle on it. You might enjoy it, might learn something. As part of your tuition, you are entitled to take these courses, so let me know if you're interested and I'll get you the license code to get in there. Well, that's what I'd like to say about Modelbuilder. So it's a really nice tool, nice way to string a bunch of tools together, a really great way to keep good documentation on how your analysis goes. It's a handy thing. So go ahead and run through the lab on this. You're going to create that exact same model that we've been looking at in the lab, and you test how it works. You're going to test how to delete intermediate data sets and how to set it to add to display. So yeah, give it a shot. Next we'll look at a very brief look at Python. I'm just going to show you what it is. I'm not going to teach you how to write it, but I'm going to teach you how you can actually use it and create Python code to use without knowing how to write it. All right, thanks so much.